So, first of all, I would like to send a warm welcome to everybody seeing and listening this presentation. And secondly, great thanks to our friends in Estonia, to RMK, who invited me to give this presentation today. And yeah, I'm happy to do that, to have the opportunity to speak to you. Who am I? My name is Wolfgang Beck. I'm the managing director of Mercer Holz. Mercer Holz is the wood purchasing company of the 3 Mercer mills in Germany, which means 1 sawmill and 2 pulp mills, Stendal and Rosenthal, and the sawmill is in Friesau. Altogether, we are consuming in the 3 mills roughly 7 million solid cubic meters per year. Only to give you an impression what my company is doing. So I would like to start my presentation, which is about the climate change and the climate policy challenges for the wood industry in Europe. I would like to start with some facts and figures, only to bring us all on the same page. I'm talking about numbers which are pre-calamity numbers, which means in the year 2015, 16, 17, these numbers were relevant. And of course, in the meantime, there is some change, but I'm coming later to that. So all over Europe, we are roughly talking about 250 million hectares of forest area. 170 million are available for wood supply. 113 is coniferous forests, 90 is broadleaf forests, and roughly 50 million is mixed species forests. Here's an interesting other KPI. I would like to show you the development of the growing stock. And you can see here in the year 1990, the development until 2015. So we start in 1990 with an overall stock of 25 billion cubic meters outside in our forests, and we added only in 25 years 10 billions in all over Europe. So from 25 to 35, even though we had full felling rates and also climate-related calamities, which of course are not comparable with what we have seen in the past years, but they took already place earlier. And of course, the reason we know this today are the higher temperatures, which we already had, and the nitrogen levels in the atmosphere. So in the years in the 1990s, in the year 2000, and later, we had perfect growing conditions more or less all over Europe for our trees. What does it means, or what does the climate change development means in Europe in the past decades? And I would like to start with the temperature. Of course, this is more or less in the meantime clear to everybody, but I would like to show it here. So the black line is the baseline. It's the average in the years between 1981 and 2010. And we can clearly see that before 2000, more or less the temperature was lower than this time period. And afterwards, after 2000 until now, it's increasing every year. And yeah, maybe in the last years, it's not only linear, it's exponential increase, what we can see. If we look to the precipitation, situation is different. Maybe some of you believe that also precipitation comes down. This is not the case, but there's also a huge change, and it depends on different locations where you are all over Europe. So basically, precipitation increases if temperature increases, which is logic. Higher temperature means more water coming from the oceans into the atmosphere, and at the end, of course, we have higher rainfalls. It's a little bit a question, when does it rain? Is it in the summer or in the winter? At the end, the higher rainfalls does not really mean that our trees can utilize it. So higher precipitations in winter does not really help in the summertime. Only to give you an impression, if you look to Germany, and we can see here the drought monitor all over the years from 1952 to 2021. Yeah, what can we see? There has always been drought. This is nothing new. For example, in 1976, it was very dry in Germany. But what is really special in the year starting with 2014 and becoming a real intensive trend starting in 2017 and 18, we had intensive drought over a couple of years with the results we already know. And if I say already know, I would like to give you an example. And here is a slide which combines Germany, Austria, and Czech Republic. So let's say Central Europe. What happened? I would like to start with the red bars. The red bars show the development of the damaged timber. It was quite low volume in 15, 16, and 17, and then increased after 17 to a huge amount. So it sums up to more than 120 million solid cubic meters in these three countries, which maybe is something like a permanent storm. So that's the red bars. Then we have the green dotted line, which is the average of the harvest before the calamity. And we have the blue line, which is the real harvest. And of course, if we have a real harvest of roughly 120 in the years 2019, 20, and 21, and we have exactly the same calamity volume, this means that if there is always fresh cuttings, that some of the damaged timber remains in the forest, and this is what we can see all over Central Europe. If we look into the forest, we see a lot of dead trees remaining there. So talking about the future, and of course it's not really easy to project what will happen in the future, but let's try. So some of the some tried it, and let's talk a little bit about the scenarios. So if we talk about different scenarios, we talk about the RCP scenarios and the numbers behind RCP. That if we look to that numbers here, 2.6 up to 8.5 means the energy which stays in the atmosphere, and this is very much dependent on the concentration of the greenhouse gas in the atmosphere. So at the end, if sunlight comes to the Earth and it goes back into space, some of the energy stays in the atmosphere, and the portion which stays in the atmosphere is higher if the greenhouse gas concentration is higher. And this is measured in watts per square meter, and the numbers here show the watts per square meters. So when these scenarios were built up, the scenario 8.5, which means 8.5 watt per square meter stays in the atmosphere, was the worst case scenario. In the meantime, we know that it is maybe the most realistic one. But when it was defined as the worst case scenario, and it was defined as the scenario where not any special mitigation measures are done, and this leads to a situation where the greenhouse gas concentration leads to this 8.5 watts per square meter staying in the atmosphere. So If we look to the temperature, and I would like you to focus on the pictures in the middle. If we look to the temperature, and we look to the years 2030, 50, and 70, there is a difference between different areas or different countries in Europe. So the picture here and the pictures down are absolute temperatures, but the change, and this is the relevant pictures here, the change is showed in that pictures. So green means more or less good, not really a change in the temperature. Yellow is not so good. Red is really a huge change, and we can see in 2070, more or less all over Europe, there is a huge increase in temperature. It's different in 2050, and it's much more different in 2030. So there are still areas in Europe remaining, especially in Scandinavia, where the temperature increase is compared to the other areas quite low. If we look to the precipitation, and again, we focus on that pictures here because they show the change, and we start with 2070, more or less in all parts of Central Europe, precipitation is reduced, but not in Scandinavia and in Russia. The same in 2050, more or less the same picture, and a different picture in 2030, where we have a lot of different colors here. Still some blue colors in Central Europe, but we can clearly see in Central Europe more red compared to the northern part of Europe, to Scandinavia. So at the end, we can translate the precipitation and the temperature development into the annual increment, which is influenced. And again, we look to the change. Blue means positive, white is more or less neutral, and red is negative. And again, Scandinavia shows a positive trend in 2030, in 2050, and in 2070. And when we look to 2030, it's still not really a huge change in Central Europe, but the annual increment is reduced latest in the 2050s and much more reduced in the 2070s. So what does it mean? Precipitation would significantly increase in North Scandinavia, as I already said, and in Russia, and will be reduced in Central Europe. And the annual increment will decrease in Central Europe by roughly 15% in 2070, but we see a positive effect in Scandinavia. Coming to the second part of my presentation, and it's about the climate policies of EU. Starting with the overall target of the Green Deal, which means the plan is to be climate neutral in 2050, and compared to the old plans, the target is much more ambitious. Means that we want to achieve in 2030 a cut of 55%. Compared to the old target, which was only 40% of the greenhouse gas emissions. And this means, again, that all the EU strategies and regulations need to be adapted. And from our perspective, what we see and what we recognize in the public discussion, in the discussion within the EU, is that managed forests are not yet being sufficiently recognized as a proper tool against the fight for the fight against the climate change. If we come to specific questions, and here I only show some examples where we see problems with the EU policies. So, for example, EU taxonomy is not fully aligned with the sustainability requirements established in RED II. Here's one example. Everything which is produced on food and feed crops is not considered along the EU taxonomy sustainable. But on the other hand, in RED II, it is included. Another point which is of relevance is, let's say, the influence we believe is coming from the EU compared to the respective countries. If we talk about the biodiversity strategy, the forest strategy, and LULUCF, there is a high risk, or maybe a high likelihood, that influence from the EU becomes stronger and stronger in that areas, which means that there is a shift more from the national level to the EU level. Could mean that bioeconomy, the understanding of bioeconomy is in the future a little bit reduced to what we know today, as of course the states are more focused on what is going on in their areas. So here there's an overview which is quite detailed. I don't want to focus on each and every detail here, but here's an overview about the different policies, different EU policies, and what it means for the wood market, and at the end for the wood consuming industry. So on the first page here, you see the biodiversity strategy, the forest strategy, and LULUCF. And at the end, the risk we see is that conservation of forests becomes more relevant in the future, driven by these strategies. And this means, of course, on the other hand, for us, decrease of wood availability and increased wood prices. Second slide. It's about EU ETS and RED II, EU taxonomy. At the end, also to condense it to the main point, the risk we see is that the support of wooden biomass for energy or biofuel production means for the established wood industry that their raw material is maybe reduced. And again, it could mean for the material use that the availability of the raw material is reduced, and we see increased prices. And on the last slide here, regarding the implications, it's about the carbon market, and the situation here is different. So it can mean positive things to the wood consuming industry. It can mean negative influence depending on the projects, if they support professional forest management or not. And in the aftermath of this support, there could be an increased wood availability, but it could be also the opposite, depending on the nature of the respective project. So we see a chance here, but we also see risks. So at the end, to conclude my whole presentation, the effects of the climate change in European forests vary widely and depend mainly on different things. So of course, reaction of the society, which is of course, ongoing at the moment. We are in the middle of this process. It's very relevant. Of course, the region is very relevant. The landscape is very relevant. The type of the forests and the type of the forest management is very relevant. Effects on forests are different all over Europe, but what we expect and what we already can see is that there is a shift of the optimal growth areas of different species. So what does it mean for spruce in Central Europe? We can see that there is there is high calamity volumes, and if development goes on, which we can expect, maybe some of the established tree species disappear in some areas. Then the increase or decrease of stability and of course the productivity of the forest ecosystems, the increase of water and heat stress, and the change of the ecosystems at the end are effects which we already know and see in our forests. What is the risks? So the question is how the politicians and also the societies react on the climate change. The revision of the EU policies I already touched. The fight with other wood-consuming investments is a problem which is discussed in the different markets in a different way. So, for example, here's one example which is discussed right now in Germany is the conversion of coal fiber power plants into plants which can use, maybe not to the full extent, but maybe to a high part, can use wood for burning. And the last point, which is not clear, I have to say, from today's perspective, is the way how forest certification schemes really react on the need or on the, let's say, on the different developments, on the new development of the climate and what it means for the need of the forests and the question is how the schemes are really able to react on that. What is actions we should do from the perspective of the wood-consuming industry? So, of course, society needs to react. This is not a question. Forestry research has to be intensified. This is a thing we support. Then we need new forest structures and adapted tree species. Also, this is supported by us. We want to lobbying much more in the future to support the usage of forest products. We are quite successful already, but we need to do more here. We already discussed about the EU policies. We have to make clear towards the politicians, towards the EU, that managed forests are better to mitigate the climate change than unmanaged forests. And of course, if it really comes to CO2 reduction, we have to improve our logistics, our wood logistics, in a way that we also contribute to reduced CO2 emissions from that perspective. So that's it from my side. Thank you for attendance. And I'm ready to answer your questions if there are some. Thank you.